My name is Murray Oldfield. I'm a technology architect at InterSystems. What I want to do today with this session is introduce Hyper-Converged Infrastructure. It's in some ways the new kid on the block. It's been around for a few years now, but I'm just starting to see customers investigate it, and a couple even start using it. So what I want to do today is just set the scene, and hopefully you'll go away with a bit more information about it. Can I get a show of hands of the customers here? Anybody using it for any part of their organisation already? Oh, okay, so one. Does anybody here have a good idea what it is already? Okay, so sort of a third of the room. So that makes it easy. I can pretty much tell you anything. So part of my job is to talk to customers about capacity planning and infrastructure, and I typically talk to CIOs and IT departments and technical people, usually about the time they're doing hardware refreshes. So the sort of questions that start to come up are, should we be replacing our existing architecture with something new like HCI? Should we be going forward with what we have but newer? So hopefully this will start to set the scene and give you the questions that perhaps you could be asking as you go forward and talk to the vendors. So we're going to start off with just a set the scene, get everybody on the same page about what is HCI, what it might be good for, and perhaps what it might not be good for. We're going to look at some benchmarks that we've been running recently to let you know how it performs with cache, which is really important for us. And I'm going to finish off with, there is a different bunch of words and languages you'll hear as you start to get into this HCI. So we'll try and clear up a little bit of what that is and give you an idea of the things that you should be considering if you're moving to HCI, so that when you have conversations with your vendors, you've got somewhere to start. For a start, hyper-converged is a made-up word. If you go and look for it, it doesn't exist. It's really a marketing term, and it's a way that people can differentiate hyper-converged from converged and other things. I'm standing here today talking about hyper-converged, but it does remind me of maybe 5 years ago what I was doing at Global Summit talking about virtualization. At that time I had a room with about this many people in, and when I asked how many people have virtualized their cache databases, their tier 1 business critical applications, there was just one or two. And we're at the point now where, outside the US, InterSystems sells an EHR system called TrakCare, and our default architecture for that is in fact virtualized. So most of our customers are virtualized. There's no reason not to do it, except for some corner cases. And if I asked all you guys to put up your hands, if you've got virtualized infrastructure for your cache databases, you probably all put up your hands. So, we're at that point again where there's been a shift, there's been a change, and we've got to decide what we're going to do next about it. Is it right for me or not? So, your legacy stuff. So this is your old school separate servers and storage. You go to vendor A, you might go to Dell and buy your servers. You might go to EMC and buy some storage, or go to Pure. So this is this idea of my dodgy old laptop, I think, is the cause of the screen going on and off. So, this is where everything's in tiers or silos, where we've got server guys, storage guys, network guys, and that's how most organisations are structured, except for the smaller ones. And then we have converged. So what converged is where you might have individual components still, but you're buying them from all one place. So you might be buying Cisco and Pure, and that might be called a flash stack. So you're actually still getting separate servers and storage, but from one place. And what do you get for that? Well, you get a single SKU to buy from, but you also get all that proof of concept and that matching up of software and hardware already done for you. Somebody has already made sure that all of these little Lego set pieces fit together. You might not have the flashest, newest, hot off the press, CPUs or maybe even the storage, because it takes time to validate all of this stuff. But you do get the comfort of perhaps getting this thing shipped out from the factory with your specifications, and really all you've got to do is put in IP addresses and so on, and then it's up and running. So that's converged. Hyper-converged is a different thing again. We've collapsed this down even further. And so what's happening here is that if you go to Nutanix, for example, you can buy a block with four servers in it, with all the storage inside the hosts. You can also go to the vendors like Nutanix or VMware and purchase the hypervisor level stuff from them and purchase the server and the storage that's inside it from somewhere else. But the key to bringing all this together is that there's very strict hardware compatibility lists. You really have to stick to that, if you roll your own. This is our typical infrastructure for TrakCare, or for it's a real cookie cutter for a virtualized solution. The main things are we've got a bunch of hosts in a cluster, and we've got a storage array which has a storage controller, some read-write cache, and a bunch of disks, which will be carved up into some LUNs. Now, if I change that picture to hyper-converged, you can see what's changed. Anyone want to hazard a guess what's changed here? 1, 2. Anything you see changed? There's a koala bear. Solid-state drives. That's part of it. Oh, you get a bear. The other part of it is that the actual storage array has disappeared. So the disks are now in the hosts themselves. There's something else that's changed. Anyone notice one of the VMs disappeared? What disappeared? Yeah, it's a little bit hard to read on that screen. One of the mirrors disappeared, so we'll talk about that later on too. So I'll save that for you. So what the key is to hyper-converged. Why is it hyper-converged? It's hyper-converged because now we have the storage in the hosts. So if we go a bit closer and have a look, it is all about the storage. So we have now tiered storage. So it's typically the vendors will break this up into a cache tier and a capacity tier. So the cache tier is where data is written, and the capacity tier is where it's eventually stored. The capacity tier on all flash arrays, the cache tier is 100% write cache. There's no read cache there. There are the option of a hybrid array or a hybrid solution, which means that you've got spinning disks for your capacity tier. Really, the recommendation that I would be giving any customer is just go all flash. Don't use the spinning disks. Today, there's not an awful lot of reason to do that. The SSDs have the capacity, and they also bring with them the really low latency and excellent performance. The other thing that's going on is when you had a shared storage array, you would use LUNs, for example, to carve up where you're going to put your data. You would have maybe a LUN for your journals and some for your data and a different one for your backup. With all of these solutions, you're using storage policy-based management, which means per VM you can start to make decisions about availability and performance. So you could put your primary database, you could configure that for extra high availability and the best performance. But if you have on the same cluster, for example, your test or dev systems, you can make them maybe a little less performant and available, but that's going to make your storage go a lot further. So we'll talk about that a little bit later. So in summary, HCI is all about the storage. That's the big difference to the old way of doing things. So let's have a look at what it could be good for. And what I want to do before we go down this path of how you're going to use it or where, is to say InterSystems' position on this. Now, we release our data platforms based on processor and operating system. So if you're running Red Hat on Intel x86, that's supported. If you're running AIX on Power, that's supported. If you're running it on virtualized, the fact that you've got a hypervisor there abstracting away the actual infrastructure, that doesn't matter. We still release for the operating system running on x86. And that's been the case all along. So if you ring the WRC with some issue to do with the data, with the database, we're not going to ask you to replicate it on bare metal. The fact that it's virtualized really doesn't make a lot of difference to us. So for hyper-converged, it's the same story. The fact that you're running Red Hat on VSAN or Nutanix AHV on x86 chips, it's still supported because we're supporting the processor and the operating system. The problems I see aren't to do with the hypervisor usually. The problems we see are to do with performance, and we get those on any sort of system, and they have to be solved. So what are the benefits? We have the day one and day zero sort of thing. So this idea that you can just buy everything in a block, it comes from the vendor, you can stick it in the rack, give it some IP addresses, and you're using it within a few hours, and that's fantastic. But really, the difference with these things is the day two, and day one is just a very tiny part of the life of this infrastructure. So it's how you do your operations and your management and how the system is going to be managed in the long term. And the vendors put a lot of effort into making that a lot simpler. And some of this complexity that you had with LUNs and so on is taking away, where you're dealing with things on a per VM level now, and you can start to tailor things. There is potential cost savings. You got rid of your storage array. But remember, the storage array still was doing things. It still had processing, whether it was doing deduplication or whether it was just putting the storage where it has to go. That processing still has to be done somewhere, and where it's done now is up in the host. So there's still, that has to be taken into consideration. There's other things too. If you're going from old infrastructure to this new stuff and you're using all SSDs, then you're going to find that you've got, power and cooling is going to be lower. One of the things you should be doing though is not comparing hyper-converged to your old infrastructure. You should be comparing hyper-converged to what you would be buying new if you weren't buying hyper-converged. But if you talk to the vendors, I'm sure they will help you work through the TCO. And this idea of scale out, everything is virtualized. That's the one thing that is mandatory here. You can't have a mix of bare metal and virtualized typically. So the idea for virtualized is to always right-size your VMs. So what you might want to do is start with the infrastructure you need for 3 years, and then plan to add nodes and add capacity for CPU and storage over time, because you can actually scale these things as required. You just add another host with some more storage. Now you've got more CPU, and your storage is just growing because the storage is just a big pool. The fact that it's on separate servers means nothing. It's actually shared. So what's it good for? Well, it pretty much started in VDI, and so it's really good for that. And then it started to be used for more mission-critical things like Exchange, and now it's deployed on databases. So, tier one mission-critical databases. It's used for SQL Server, it's used for Oracle. As I said, we're not really seeing it out there for cache at the moment, but I think it's just a matter of time. So, when might it not be the good thing to do? If you have a very small implementation, we sell TrakCare outside the US to the whole country of Chile, or sometimes even to just a small clinic in China with 10 or 20 users. And in that case, as we'll see, there are some cost to entry to hyper-converged that perhaps these really small sites can't afford or don't need. For a very small site, you might just, for example, just have a bare metal server, use cache database mirroring for your high availability, and then just have, the cache instances running on the Red Hat or whatever on bare metal. So there are cases where it's just not going to make sense. And the other end is if you've got very unbalanced workloads. So if you've got requirement for very, very large systems, monster VMs that require a lot of CPUs, then you're going to have to think about how you do your availability. To accommodate that, you're going to have to buy very big servers. And along with, if you're going to have a cluster that's all the same size, then what you're going to be doing is growing that at those increments. And as we'll see, there are some minimum numbers of servers that you're going to need. So you're going to have to think about, does that make sense as well? If there are bare metal workloads, they're not really going to be appropriate. And the layer 8 type reasons. So within your organization, if you do have silos and you have server guys and storage guys and network guys, are the storage guys going to be happy that the server guys are buying the storage now and managing it? So those are things that you're going to have to solve. So to sum up this section, I just would say that, look, you're going to have to have a look at it. You're going to have to start to decide whether it's the right thing for your organisation. And as we'll see in a few minutes, there's some other things that you're going to have to take into consideration. So I'm going to show you the results of some benchmarks we did. I'll just, because we're running out of time, I'll just go into it. We do benchmarks with TrakCare, the application that we sell outside the US. And within that application, we keep a lot of metrics. We keep information on how often components are called, how much global references they do, all of that type of data. And from that, we can actually look at a site or look at many sites and understand what are the workflows and what are the parts of the system that are using the most resources. And then we can put those together in scripts and we can run them. And the idea is to simulate like what would be happening in a real hospital. And what that does is it exercises the cache database and also the infrastructure underneath. Now, typically in the past, our benchmarks have been very CPU focused. How far can we scale up? What happens when we scale up past 100%? And then we'll do some benchmark activities to try and tune the system and get the best. And out of that will be produced white papers, for example. There's two types of tests we do. One is where we have, for example, a single database mirror or a single server, and we just use the drivers that you can see in the picture to drive a workload onto web servers, because TrakCare is a web front-end application, and then it drives the database. And we can just run it at like, a set transaction rate, then we can double the transaction rate and so on, and just scale up that way until we're using all the CPU. And the other one is scale out. We just use ECP. So instead of having just a single database, we have as many ECP servers as we can scale. So the first benchmark I'm going to show you is one we did with VSAN. This one was done about a year ago. If you Googled VSAN and InterSystems and Intel, you would find the white paper that came out. The solution we came up with, this all-flash solution with NVMe drives for the cache tier and SATA SSDs for the capacity tier, was based on conversations we had with VMware and Intel, talking about what would you require for a database server. What would be the best, what would we be recommending our customers to buy? And so this is where we landed. The benchmark report itself talks a little bit more about the detail, the number of disk groups and so on. I won't go into it now because that's a bit too much of a rat hole. So the results were what we expected, to be honest. We ran out of CPU. Now, whether we're benchmarking power or some other bare metal server, that's typically where things run out. Storage just works. Now, the difference with hyper-converged is now everything's collapsed into one. So we really are testing the storage as well as testing, the CPU at the same time. The graph just going up like that in steps is what we expect. Nice linear graph. As you add load, it goes up. What's not shown in the graph is what happens when you go past 100% CPU. And what happens is it just flattens out. And those are things we want to know in a benchmark too. How does the system behave when you push it beyond its limit? So that would have been at about 80 to 90% CPU, and so that's the most we got out of the system. And the picture on the right is just the same picture but for ECP. So we can obviously scale further because we're spreading the processing load now. We use a utility called RANREAD, and we have done for a long time. It's actually you can go on the developer community. Who here goes on the developer community? A few people, well, most people. If you go on there, you can search for RANREAD. It's just a little utility you can download. We use it a lot for like smoke testing, storage arrays and so on when there's an implementation going on. What that does is it just creates a big database and then does random reads on it. And what we're looking for that is the storage set up properly? Is it going to be performant? Is it up to our requirements? So this picture is from 2012. This is not VSAN or not Nutanix. This is not hyper-converged. But this is where we were back in 2012 on spinning disks. You can see that on the right-hand side was the number of IOPS. So we were getting about 3,000 IOPS, and this is probably maybe 20 disks in a storage array. And the response time on the left, we were getting between less than 10 millisecond response time for a read. And that's our requirement. We want less than 10 milliseconds for a read at the I/O. So this particular customer, we scoped out that they would hit 2,000 IOPS, at peak load. So it got a tick. It was okay. So this is the picture for VSAN. Now we're getting 30,000 IOPS at less than a millisecond response time, 600 microseconds. So you can see we went from spinning disks to flash, a huge improvement. And remember, this is a read. So in the way VSAN works is the reads come off the capacity layer. So this is off the SATA SSDs, not even the really fast NVMe layer. So these are the sort of things that make a huge difference. The IOPS is great, but you do want to size your system to minimize the IOPS. A cache system is an in-memory database. You want to have nice big global buffers, and you want to keep the I/O actually pretty low. It's not unusual for us to see a big hospital doing less than 500 IOPS for reads. So this is way more than they need. The thing we really care about, though, is that blue line, the latency. Low latency is great for databases. So whether you use hyper-converged or not, flash is the way to go. Okay, we're in the middle of a benchmark with Nutanix as well. So Nutanix using AHV, so we're not using vSphere, we're using Nutanix as hypervisor. There's sort of a joke we have in our group that when we do benchmarks, it might take a month to do the benchmark. We actually don't really get good results until the last couple of days because we futzed around with the benchmark scripts and the tuning and whatever. So this is very preliminary results. So I want to be very clear about that. I also want to be clear that this is not an apples to apples comparison between VSAN and Nutanix. Okay, so I just want to set that scene for you. Even so, we're still getting excellent performance. It's marching up in a nice linear way, and the I/O performance is excellent as well. We're getting less than 600 microseconds and 50,000 IOPS off the Nutanix. So, early indications are that this is going to be just great as well. So let's dive into some of the jargon and the things that are different with HCI. The best place to start, so this is a screenshot from the community page on the developer community. All my posts I put under an index. So if you search for capacity planning and performance series, you'll hit this page. And the After the VSAN testing, I wrote a post on Hyper-Converged and my recommendations for the choices, because there are choices. Just because it's an appliance, it's not a toaster, okay? So you can't just plug it in and it works. You've still got to do some stuff to set it up. VMware best practice. If you're running on VMware, all the same rules apply. You know, reserve your memory. It's cache, it's an in-memory database. Use PV-SCSI for your storage interface and so on. So virtualizing large databases, I talk about noisy neighbors and not to put too much on one host, and the other things. And of course the cache documentation, if you're setting up Red Hat, the same rules apply. So the message I'm trying to give you here is, yes, we have some resources, but just because it's hyper-converged, it's not really that different as far as cache and the VMs are concerned. CPU and memory, same considerations as normal. As a rule, I would add just 10%. Remember, we're moving that processing that was on the storage array up into the machine. So that's probably conservative. By conservative, I mean it's probably overstating what's required. But if you do that, at least you can size your machines and be comfortable. We're at the position now where, for TrakCare, for example, we don't have we don't have any customers using it. So we can't sort of go back and say, well, we actually know what's going on. So we've got to start somewhere. So I suggest you do the same. Deduplication and compression. So these systems come with the option to dedupe your data and compress it. And part of the reason for that is because you're putting everything on flash. Flash, IOPS per gigabyte is very high, but the number of gigabytes per dollar you get is actually less than spinning disk. So one way to counteract that is actually to compress the data, so there's less data actually sitting on the storage. At the moment, my recommendation is just don't be deduplicating your database, because you can't. Databases are made of 8K blocks, which have got pointers and different data, so they're not going to deduplicate very well at all anyway. And there's an overhead to doing that. And until we do some more testing, that's going to be my recommendation. Encrypting, you can also turn on encryption. Now, this is something you might want to think about anyway. You want to encrypt depending on where you think your risks are. If you encrypt just the storage, you're planning for people to pull the storage and walk away. And if you've got flash storage, it's pretty much encrypted anyway. If you encrypt at the VM level, you're going to stop people copying a VM. If you encrypt at the cache.dat level, you're going to stop people taking a cache.dat out. So where you see your risks is where you should be encrypting. If you encrypt at the cache.dat level, the warning is, of course, that won't compress or dedupe. It's all going to be random data. So you've got to think about these things. There's some weird names that come up the first time you look at this, object space reservation. Well, strictly speaking, they've actually described what they're doing here, but what they're actually doing is thin or thick provisioning. With VSAN, you can choose this or not, and the reasons aren't so much performance related. They're actually what I call the layer 8 issues, the humans. If you have your jewel in the crown database and you thick provision it, you reserve all that space, no one else can take it off you. So that's a good reason to do that. And maybe database expansions will be a little bit faster. With Nutanix, it's all thin provisioned, and their magic will take care of that for you. But this is thick and thin provisioning. Just thin provisioning means that I might say I've got a terabyte database, but it'll only allocate the disk as it needs it. So that way you can actually get more consolidation. My preference is thick provision if you can for your database. All right, so this is something I want to talk about because it does have a big impact on your capacity planning. How many copies of my data are there? Now remember, we saw that picture, each host has its own storage. Now a VM is just a bunch of files. Your VM is made up of some files on the disk. The reason you have shared storage is because you can vMotion your VM from host A to host B. And you can still see your data, and you can still see what makes up the VM. So how do you do that when everybody has their own storage? The way Hyper-Converged works is it writes data to one machine and then to at least one other, and all the machines are connected together. Now it writes them to multiple machines for availability. If I only wrote to one machine and that machine got taken out for maintenance, I've got no data, or I've got bits of my data missing. So there's this idea, how many copies of my data do I need? VMware calls it failures to tolerate. So how many concurrent failures of host, network or disk am I wanting to have protection from? Nutanix calls it RF, or replication factor. So by default, everything writes RAID 1. I write once to somewhere and I write once to somewhere else. Now I've got two copies, and it creates a little witness object too, because if there's a split brain, then you need to be able to decide, who's got the real data and who should I keep updating. But the knock-on effect is, how many hosts am I going to have? Remember I said that very small implementations might have a barrier or a bar to get over. And this is why, databases are, you can't lose your data. We're all in healthcare mostly. If your data is absolutely must be available. So the very simple rule is, if you need RAID 1, then you need 1 plus n plus 1 replicas, because you must also have the witness. I just realised I made a spelling mistake, sorry. You need plus the witness. So if you have 3 hosts available at all times and you're going to be doing maintenance, then you actually need 4 nodes. So the minimum requirement would be 4 nodes. If you have failures to tolerate as 2, then you're going to need 6, because it's 2n plus 1. So you see where I'm going with this. You're going to need 200% of your data. If you do 2, you're going to need 300%. The way to get around this is with what they call erasure coding. So essentially RAID 5 or RAID 6. For production databases, you're probably going to be wanting to do the RAID 1 option. But for your non-production, you can spread it out. Now, the cost to that is that there are, once again, minimum numbers of hosts. If you do RAID 5, you need a minimum of 4. If you do RAID 6, then you need 6 nodes. So you've got to work out, you've got to take this into account when you're doing your capacity planning. It's not like the old days, I've got an array, I've got this many disks. I'm not saying this is a problem, I'm just saying you've got to think about it. Okay, so I'm going to finish up. Mirroring is possible, and I've got Oren in the room. He's actually the product manager for mirroring. But is it a good idea? Anybody have any ideas, plus or minus? Who thinks mirroring would be a good idea? Okay. Of course, Oren does. Mirroring is a good idea because it gives you availability. Now, if you're running on AHV or vSphere, then you've got, like VMware HA already, you've got some high availability that came along with the platform. What cache database mirroring gives you is that little extra fast failover, because our mirror is running all the time. If a host goes away and a VM has to restart on another host and come up, you've got all that time for operating system restart, cache recovery, and then users connecting. Whereas with mirroring, you can fail over in less than 20 seconds, probably 10 seconds. If there's a cache failure, the mirror will take over. If there's an application failure that causes a cache failure, the mirror will take over. So mirroring is a good idea, and it can still be used in virtualization. But one of the things that you've got to take into account is, remember what I was talking about with capacity? You've got multiple copies of your data. Now we've got multiple copies of multiple copies. You're blowing out your storage, and you've got to decide, is that really what I want to do? Is the extra availability worth the capacity? What is my risk? If you're using deduplication, well, you're going to, and you do it on a cluster-wide scheme, then you're going to be deduping your mirror. You've just lost the data separation that you also get with mirroring. These are considerations. So one way to approach this is to have just treat it as failure domains. Have 2 clusters. Have a mirror in each cluster. That way you're going to get your high availability. Once again, is your organisation or your requirements going to justify that. But there isn't. I would recommend you do mirroring if you can, but just think about how you're going to do it. So I'm going to wrap up.
Just a comment on that, Murray. You can configure different fault tolerance for the backup fault, therefore slightly reducing the storage requirement. Now when it fails over, we're less protected.
Yeah. That is true. Like, there's probably strategies around that. Ideally, though, in a mirror, you want to have like for like.
Yeah.
You don't want to be. There is no primary and backup, although we sometimes call them that. They're just mirror A and mirror B. The fact that I'm on mirror B today shouldn't really make any difference. Down the track, I might be on mirror A. I don't want to be failing over just because he's not performant. But as ever, the best answer. It depends. There's all sorts of ways of approaching this. So in summary, certainly there's no reason not to consider HCI. For performance and availability, don't even make it a question. Just demand all flash if you have any say in this at all. If you do roll your own, you have to strictly follow the hardware compatibility list of the vendors. Of the HCI vendor. Even if you have a storage card in the host and a firmware upgrade comes out from the vendor, you can't apply it until you've talked to your Hyper-Converged. And then they'll advise you how to upgrade. I've seen that, early on when we were doing our benchmark testing, we applied some firmware updates and made things not work. I can't overstate this enough. You have to be really compliant. Start with your virtualization best practice and have a look at the community of some of the advice I've given. And talk to your vendors. We're more than happy to get involved, but really they're the guys with all the knowledge. I know what I know about VSAN because I did the VSAN benchmark. I'll know a lot more about Nutanix by the time I finish the Nutanix benchmark, and I'll probably do a blog post on that as well. But really, the vendors are going to be your best advice. Talk to us about how to do your capacity planning for cache and our requirements for VMware best practice, and then try and overlay that on what they're going to advise you. They're going to want to help you as well. Maybe start off with a proof of concept. I talked about all this thing about data compression and deduplication. What does it mean for your application and for you? Maybe start off with dev and test. Get to know this stuff. But definitely it's something that we're going to just see more and more of it over the next few years. Please complete the survey. Please don't beat me up too much for having a dodgy laptop. And I think it's time to go to the casino. Thanks very much.